Dear students, welcome to online class. I am Sudipayan Bhattacharyya. I am going to discuss about relations and functions in this class. This is my second lecture on relations and functions. In my previous lecture, I have discussed about Cartesian products and relations. Today we are going to see what function is. This class is prepared for class 9 and 10 basically, but anyone having the concept of sets can understand this class. So, why waiting? Let's carry on. Topics that will be discussed in this class are relation. We have studied about relation, but we are going to get a revision. Functions, domain of a function, range and codomain of a function. We are not going to solve any difficult problems regarding range and codomain, but we are going to discuss range and codomain from very beginning, from the basic. So it's concept based. A revision of relation. A relation is simply a set of ordered pairs. A is a set containing 1, 2 and 3 and B is a set containing 2, 4 and 6. Then two examples of relations are as follows: R1 and R2. Here you can see in R1, 1 is mapped to 2 and 4. 2 is mapped to 4, 3 is mapped to 6. So the relation is 1, 2, 1, 4, 2, 4 and 3, 6. R2 is another relation where 1 is related to 2, 2 is related to 4 and 3 is related to 6. So the relation is 1, 2, 2, 4, 3, 6. R1 and R2 both are actually set of ordered pairs. First elements are called pre-images and second elements are called images. In mathematical relations, the mapping from pre-images to images are often described by one or more rules. For example, if we take our first example, R1 is a relation from A to B. So R1 is 1, 2, 1, 4, 2, 4 and 3, 6. Y is representing the second elements and X is representing the first elements. Then every second element is 2 times of the first elements, or every second element is 4 times of the first element. Now we can see a set of ordered pairs x, y. X belongs to A, Y belongs to B, where Y is equal to 2x or Y is equal to 4x. Here R1 is written in set builders method. Previously we have written R1 in tabular method. Here R1 is written in set builders method. If we take our second example, we can see R2. R2 in tabular method we can write 1, 2, 2, 4, 3, 6. Can we define any rule for R2? Yes, we can define a rule. The mapping can be described by y is equal to 2x, where you can see y is the second element and x is the first element. Second element is double of the first element. So the rule is y is equal to 2x. R2 equal to xy such that x belongs to A, y belongs to B, where y is equal to 2x. Now pause the video and solve these two problems by 5 minutes. At least try your best to solve it. If you can do it, better. If you cannot do it, don't be worried. You can do it later. If we compare between following two relations, we can see a difference which leads us to the idea of function R1, R2. In the relation R1, there is a pre-image which has multiple images. Look at 1. 1 has two images. This characteristic of a relation is the limitation for it to be a function. Hence, R1 is not a function. In the relation R2, we can see that there is no pre-image having multiple images. Each of the pre-image has only one image. So this characteristic of R2 allows it to be a function. So R2 is a function. The definition of function is: a function is a special kind of relation in which there is no pre-image having multiple images. For example, let's take f is equal to 1 2, 1 3, 2 3, 1 5. It's not a function because the pre-image 1 has 3 different images 2, 3 and 5. But f is equal to 1 2, 2 3, 3 3 is a function because none of the pre-images has multiple images. Is this a function? Look, pre-image A has 2 images, so f1 is not a function. Is this a function? Look, A has only one image, B has only one image, and C has only one image. So f2 is a function. Is this a function? Look, A has only one image, it's -1. B has only one image, it's -1. And C has only one image, this is -1. So none of the pre-images A, B and C has multiple images. Therefore, f3 is a function. Is this a function? Look, A has only one image, it is 0. C has only one image, it's 1. But B has two images. Therefore, it's not a function. So if any pre-image has multiple images, then the relation is not a function. We are going to look at functions from another point of view. A function is a special kind of relation in which every ordered pair has different first element. For example, f1 is equal to 1 2, 2 3, 3 1, 1 3. It's not a function because there are two different order pairs having same first element. But f2 is equal to 1 1, 2 1, 3 1, 4 2. It's a function because each of the ordered pair has different first element. Now question is f3 is equal to 2 1, 2 1, 3 1 is a function or not? Though f3 has two ordered pairs with same first element, those pairs are indifferent because second elements are also equal. In the reduced form, f3 is equal to 2 1, 3 1. Therefore, f3 is a function. Now, we are going to consider pre-images of a relation as inputs and images as outputs. We can consider pre-images of a relation as inputs of a system and images as outputs. For example, looking at the following diagram, we can say that the inputs are A, B and C and the outputs are 1, 2, 3. When we use an input A, we get an output 3. When we use an input B, we get an output 1. When we use an input C, we get an output 2. Now we are going to define functions using input and output. A function is a rule for which each input returns a unique output. For example, f1 is equal to 1, 2, 2, 3, 3, 4, 2, 1. It's not a function because the output of 2 is not unique. We may get either 3 or 1 as output of 2, but f2 is a function because each input has only one unique output here. So we have an idea of function. Now we are going to see the notations. Functions are generally denoted by the following English letters: small f, small g, small h, capital F, capital G, capital H, small y, capital Y, etc. The functions might be denoted by Greek letters also, like rho, phi, psi, theta, sigma, etc. Traditionally, a function is expressed by its mathematical rule, such as f of x is equal to 2x, g of x is equal to x square minus 1, y is equal to 3x square plus x minus 1, etc., where f, g, y, etc. are the names of the functions. X represents the inputs or the first elements. The expressions at the right sides are the working rule of finding the outputs. For example, let's take g of x is equal to x square minus 1. Here g is the name of the function, x is the input, and x square minus 1 is the working rule for calculating outputs. So we can say g of 2 is equal to 2 square minus 1 is equal to 3, as it was in x square minus 1. Here we replaced x by 2, which means if input is 2, output is 3. G of 9 is equal to 81 minus 1 is equal to 80, which means input is 9, then output is 80. G of 0 is equal to 0 square minus 1 is equal to minus 1, which means if 0 is the input, then output is minus 1. Suppose A is equal to a set containing 1, 2, 3, 4, 5, 6, and B is equal to a set containing 2, 3, 4, 5, 6, 7, 8. A function f is defined from A to B such that f of x is equal to 2x. So what does it mean? It means the following relation: 1, 2, 3, 4, 5, 6 to 2, 3, 4, 5, 6, 7 and 8. The rule is f of x is equal to 2x. That means input gets doubled. F is equal to x, y such that x belongs to A, y belongs to B, and y is equal to 2x. In tabular method we can write 1, 2, 2, 4, 3, 6, 4, 8. You may ask why we have not taken the pairs 5, 10 and 6, 12. I think you got the answer. It's because 10 and 12 are not present in B. Now we are going to have another example. From the previous example we get A is equal to 1, 2, 3, 4, 5, 6, B is equal to 2, 3, 4, 5, 6, 7, 8, and a function f is from A to B is defined by f of x is equal to 2x. Sometimes you will see that there is no set mentioned for input or output like A and B. If we change our previous example as above, I mean there is no such sets as A and B, then what happens? In this case, we have to consider that f is a relation from real number to real number. That means f is a subset of R cross R. It means that as input we have to take every possible real number, and as output we have to take every possible real number. To summarize, if in your question you don't get predefined sets for input or output, you have to assume that input comes from real number and output comes from real number. Now it's time for work. I have prepared some work for you. Please pause the video and try your best to solve this work. Keep in mind that you have to try your best. If you can solve it, better. If you cannot solve it, then you must solve it later. Domain of a function. Now we are going to learn the definition of domain of a function. The definition of domain of a function is very similar to the definition of domain of a relation. Look, set of all pre-images of a function is the domain of a function. We can say that set of all first elements of the ordered pairs of a function is the domain of a function. Just we have used the phrase first element of the ordered pairs instead of pre-images. The two are same things. Or you can say that set of all inputs of a function whose outputs are defined is called the domain of a function. Now we are going to watch a for example of domain. We are going to take two examples. For the first one, let f be a function 2 1 3 2 4 1 5 2. Here the inputs are 2 3 4 and 5. So the domain of f is dom_f equal to the set containing 2 3 4 and 5. For second example, we take f of x is equal to 1 by x as a function. Now we have to calculate the domain. Since no sets for input or output is given, we have to consider that all the real numbers who are defined for this function will be included in the domain. That is, we will consider that set of all real numbers which are valid to be used as input will be the domain. Here every real number may be used as input except 0, because f of 0 is equal to 1 by 0 and 1 by 0 is undefined. Therefore, the domain is dom_f equal to r deleted 0. Now we are going to learn about range and codomain. So what is range? Range of a function is set of all second elements of the ordered pairs of the function. Second elements means images. So you can say that range of a function is set of all images of the function. Images means outputs. So we can say range of a function is set of all outputs of the function. Now we want to know what codomain is. Codomain is a set which contains the range. In other words, codomain is superset of range. What is superset? You may not be familiar to the concept of superset. Superset is the opposite idea of subset. Like this is range and a covering set of range will be superset of range and it will be called codomain. So let us have a pictorial view of domain, range and codomain. Let A is equal to a set 1, 2, 3 and 4. B is equal to a set 2, 4, 6 and 8. F is a function from A to B such that f of x is equal to 2x, like A and B in diagram. Now rule is input will be doubled, so 1 will be mapped with 2, 2 will be mapped with 4, 3 will be doubled and will be 6, 5 will be doubled and will be 10, but 10 is not in B. So valid inputs are 1, 2 and 3. 1, 2 and 3 will be called domain. Valid outputs are 2, 4 and 6. 2, 4 and 6 are called range, and the covering set of the range is B. Therefore, codomain is equal to B, which is equal to 2, 4, 6, 8. Let's watch it again. Notation of a function. We have to learn different notation to study function, to understand the questions or understand the mathematical sentences including functions. Suppose you are given the following notation: f such that a arrow b and f of x is equal to x square. The domain of f is A, which means set of all inputs is A. The codomain of the function is B, which means the set containing range is B. The rule of transformation is squaring the input, or x goes to x square, means 1 will be 1 square, 2 will be 2 square, 3 will be 3 square. Note that range is never given directly along with the notations of function. To sum up, we can say A is domain, B represents codomain, here x represent input, x square represents output. If no specific set of inputs and outputs of a function is given, then we have to consider every possible or valid real number as input and output. Since there might be infinitely many real numbers as inputs and outputs, we cannot express this type of function in tabular method or by diagrams. We may show this kind of functions using set builders method, and for pictorial presentation we can use graphs instead of diagram. So now it's time to work. pause the video and write down this work in your copy. Solve it by yourselves. If you can solve, then it is better. If you cannot solve it, study hard, try hard. You can solve it later. Special thanks to you for your active participation. Stay home, stay safe, and be serious with your online classes. Don't forget to subscribe this channel and activate the notification using the bell icon, because it will keep you updated with new videos.